So benzene, as we know, has a molecular formula C6H6, and it's the simplest aromatic hydrocarbon. Then aromatic compounds are called arenes. Benzene has 4 degrees of unsaturation. And how do we know this? It has 3 double bonds, and the ring system itself now consists to have like 4 degrees of unsaturation. So we can say benzene is a highly unsaturated hydrocarbon. Then from our previous knowledge, we know that unsaturated hydrocarbons like the alkenes, the alkynes, and dienes. When something is unsaturated, we know that it means that it has a double bond or a triple bond. So unsaturated hydrocarbons like alkenes, alkynes, and dienes undergo addition reaction, but benzene does not undergo addition reaction. We can see the example here. This is ethene, which is an alkene. It's when it reacts with bromine gas, it will form an addition product, meaning that the double bond will be lost. What we have now is single bond, and the bromine will attach itself here to form an addition product. But when we look at this reaction right here, benzene reacting with bromine, there's no reaction, because benzene does not undergo addition reactions. What benzene undergoes is what we call substitution reaction, and then it undergoes that substitution reaction in the presence of iron 3 bromide. And this iron 3 bromide is what we call a Lewis acid. So in the presence of a Lewis acid and bromine, benzene will undergo a substitution reaction, not an addition reaction. And then it's going to form this product, which is called bromobenzene. This bromobenzene is a substitution product because what was only substituted is the hydrogen was replaced with bromine. So that's that about benzene. So let's talk about a brief history of benzene. August Keiko proposed that benzene was a rapidly equilibrating mixture of 2 compounds. This is exactly what he meant by rapidly equilibrating mixture of 2 compounds. So this is compound A and this is compound B. And these 2 compounds, A and B, are in equilibrium. We can see this sign, this equilibrium sign, that this compound A can actually change this compound B, and this compound B can actually change this compound A. But they are the same compound, they're the same benzene. But the thing is that each of these compounds contains a 6-membered ring. Now, compound A has 1, 2, 3, 4, 5, 6. So you can see that this is a 6-membered ring. Compound B also has 1, 2, 3, 4, 5, 6. It's also a 6-membered ring, and they have 3 alternating pi bonds. Now this is 1 pi bond. This is 1 pi bond. Then there's a sigma bond here, and this is a pi bond. Then this is a sigma bond. So this is what's meant by alternating pi bonds. So each of them has a 6-membered ring with 3 alternating pi bonds. So the total number of pi bonds we have in benzene is 3. 1, 2, 3. And it's also the same thing for this other structure. So that is what August Keiko had in mind when he was talking about that benzene was a rapidly equilibrating mixture of 2 compounds. Now, in Keiko's description, the bond between any 2 carbon atom is sometimes a single bond and sometimes a double bond. I'll explain. You can see that in this place now, for example, the bond between this carbon number 1 and carbon number 2 is a double bond. But in this other one, this other structure, the bond between carbon number 1 and carbon number 2 is a single bond. That is what he meant by that sometimes the bond is single and sometimes it's double. Now, we are told that benzene, as the number of pi bonds we counted there was 3. We told that each pi bond has 2 electrons. So for every 1 pi bond is equal to 2 electrons. Now we have 3 pi bonds. 3 pi bonds is going to be equal to 2 times 3 electrons. 2 times 3 pi electrons, that is 6 pi electrons. So that is that. So benzene has 6 pi electrons because it has 3 pi bonds, and 1 pi bond is equal to 2 electrons. 3 pi bonds is equal to 2 times 3 pi electrons. That is 6 pi electrons. Now, some textbooks usually draw benzene this way, as a 6-membered structure with a circle in the middle. So this circle that is drawn represents the 6 pi electrons, which is distributed over the 6 atoms of the ring. Thank you.